This video is on the objective find the unit vector. Alright, so we're going to see a unit vector is simply a vector that has a length of 1 unit, or a magnitude of 1 unit. Alright. So if you want to see more about the topic, right, before we get to the question here, click on More Instruction and look at their videos, their notes, their examples. Hopefully those all help you out. I'll show you some of those notes. Right, finding the unit vector in the direction of a given vector v. Alright, so say we're given a vector called v with a certain length. What if you were asked to find another vector that points in the same direction, but that has a length of 1? Well, this is going to involve scalar multiplication. Hopefully you recall that when you multiply a vector by a number, a scalar, it changes the length. And it changes the length by that much. If you multiply a vector by 2, it doubles the length. If you multiply a vector by 1/3, you cut the length by 1/3. So if the length of vector v, say, was 10, for example, say the length of v was 10, and I wanted to get a vector pointing in the same direction, but that was 1 unit long, I would simply multiply by 1/10. Right? 1/10 of 10 is 1. You just need to multiply a vector by the reciprocal of its length, and you'll see all that coming up. So, in addition to finding a vector's components, it is also useful in solving problems to find a vector in the same direction as the given vector, but of magnitude 1. We call a vector with a magnitude of 1 a unit vector. We can then preserve the direction of the original vector while simplifying calculations. Now, in other videos, you've seen these vectors I and j. These are some special unit vectors, right? I is just the vector where you go to the right 1 unit, right? The vector 1, 0. J is simply the vector where you're going up 1 unit, the vector 0, 1. And those are, standard unit vectors. So I mentioned this a second ago, right? They're just describing it here. So if v is a non-zero vector, right, then v divided by the length of v, or multiplied by the reciprocal of the length or the magnitude, that will be a unit vector that points in the same direction that v does. Okay. So again, they mentioned, notice that the magnitude is always a scalar, right? And dividing by a scalar is the same as multiplying by the reciprocal of that scalar, right? So dividing by the magnitude is the same as multiplying the vector by the reciprocal of its magnitude, and it'll give you a vector that points in the same direction. So they have an example here. If a vector v had components -5 and 12, remember how to find its magnitude, right? Using the Pythagorean theorem, it would be 13. So this vector has a length of 13 units. So in order to make it a vector that points in the same direction with a length of 1 unit, I would simply need to multiply by 1/13. So the components of the new vector would be -5/13 and 12/13, which they're showing you down here. And then they draw a little picture also. Here's the vector -5, 12 written in standard position, starting from the origin. And then here's the vector, pointing in the same direction, but with a length of 1 unit, the -5/13, 12/13. Right, and this is what we're asked to do. Okay. So back on my assignment here, we're asked to do the same exact thing. So given the vector w with components 4 and -2, so move right 4, down 2, find the unit vector in the same direction as w. Alright, so I'm going to go to a piece of paper here. Let me actually pull one out. There we go. I'll draw this, right? We'll draw a little picture. might not be perfect. You know, my hand drawings aren't the greatest. Now we're given a vector called W with components, 4 and -2. So I'm going to draw this in standard position. So starting from the origin here, it's 4 right and 2 down. So we're ending up over here. And here in red is vector W. Alright, should be more straight than that, but whatever, there's vector W. Now again, what we're asked to do is take this and draw another vector that points in the same direction, but is only 1 unit long. So first I'd like to know then, how long is this vector? Because if this vector is 1 unit long, I don't have to do anything. Right, so what's the magnitude of vector W? I remember the little it's like absolute value, but not. So remember, this is the square root of the sum of the squares of the components. So 4 squared plus -2 squared. That's 16 plus 4. So we have the square root of 20. That's the length of this, which is, this is bigger than 1. This is not 1. And if we want to simplify this, this is the square root of 4 times the square root of 5. So 2 times the square root of 5. All right. So for our unit vector that points in the same direction, I just take W here, take our vector W, those components, and then divide by the magnitude of W. So take vector 4, -2 there, and divide each component by 2 root 5. And we get the following. The first component, 2 goes into 4 twice. You'd have 2 divided by the square root of 5 for the first component. And then -2 divided by this, the 2's would cancel. You have -1 divided by the square root of 5 for the second component, and there you go. Alright. Now you may also be asked to rationalize denominators, right? You know how they usually don't like square roots, in the denominators. So rationalizing, I'd multiply the top and bottom of this fraction by square root of 5, so we'd have 2 times the square root of 5 divided by 5. And then same here, we'd have negative square root of 5 divided by 5. All right. And there is what they're asking for right here. Okay. And then that would look maybe like this, something like this. And I'll call this vector U for unit vector. All right, here's vector U. It would point in the same direction, but be 1 unit long. Be 1 unit long. And you can tell, you can, square this is 4/5. Square this is 1/5. Add them up, you get 1. And then the square root of 1 is 1. This has a length of 1 unit, a magnitude of 1 unit, and points in the same direction. All great. All what they wanted. Alright, so looking at all these options here, that's this last option. Okay, wonderful. Alright, so yeah, pretty, now again, there's a couple steps involved, but if you know how to find the magnitude, the length of a vector, this shouldn't be a problem. Alright, so hopefully watching me go over this and looking at the more instruction if you need to, reading the answer explanations when they come up. I'm hoping all this stuff helps you out when you work on this material on your own. And thank you very much for watching.